So if we'll be using the KVL in this loop, we have to find that at what time is the energy stored is completely magnetic. We have to calculate simply the amplitude of the current. Hello everyone, welcome to Alan Overseas. So continuing this series of 45 important topics in 45 days, in which you guys will be provided with 15 topics from each subject, physics, chemistry and mathematics. And as you all must be knowing that I'll be dealing with physics. So in today's lecture, we'll be dealing with one of the most important topics from chapter alternating current, that is LC Oscillations. So this series is very helpful for all the JEE Main aspirants, and we have the whole playlist whose link is there in the description as well. So don't forget to watch the whole playlist, as it will be very helpful for all the JEE Main aspirants. Okay, so moving forward to the topic, we all know that this topic you must have studied in the chapter alternating current, that whenever a capacitor and the inductor are connected together, so whatsoever the energy stored in the capacitor, that energy keeps oscillating between the inductor and the capacitor. Okay, oscillating, you all must be understanding the meaning of the oscillations. Like basically, initially, let's say I charged the capacitor and I connected it with the inductor without any battery, just like the capacitor connected with the inductor. So what will be the situation? Like whole of the energy that was stored in the capacitor, that will be, getting stored in the inductor. Okay, and the capacitor will have no energy then. And then after that, again, the inductor's energy will be stored in the capacitor. So one more thing that I would like to tell you, that whenever the energy is stored in the inductor, so we call it the magnetic energy, because that's the term that you will be noticing in many of the question, that when the energy will be completely magnetic. So that means it will be talking about that when the energy is completely stored in the inductor. Okay, so that energy keeps on oscillating between the inductor and the capacitor. So when a capacitor is connected with an inductor, the charge on the capacitor and the current in the circuit exhibit the phenomenon of electrical oscillations. So if we'll be using the KVL in this loop, so we can write the voltage potential difference between the inductor as L di by dt, and that across the capacitor as Q by C. And since there is no battery connected, so overall potential difference across the circuit will be 0. Now I can simply write this I as dq by dt. So it becomes L into d by dt of dq by dt plus q by c equal to 0. And this equation that we obtained, like d by dt of dq by dt, that means double differentiation of charge divided with L. So I got q by LC is equals to 0. So this equation that we obtained is the equation for oscillations of the charges. Okay, so if you can relate, this equation is very similar to the equation that we obtained in simple harmonic motion. Okay, in the simple harmonic motion, when an object was just simply connected with the spring, we had the equation for the displacement of the particle, that d2x by dt2 plus k by mx equal to 0. And the similar equation we have over here, that d2q by dt2 plus q by LC equal to 0. So if you can compare over here, that there, what the term which we were using for position, like x, here x is replaced with the charge. Okay, whatever the equation of position we had, like x equal to a cos omega t, here we have the same equation for charge, that q is equals to q naught cos omega t, where q naught is the maximum charge on the capacitor, and here a used to be the amplitude, the maximum displacement from the mean position. Here omega was used to be root of k by m, the coefficient of x basically. Here the coefficient of q is 1 upon LC, so omega will be 1 upon root LC, right? Now, differentiation of position used to give us the velocity. Here the differentiation of charge will give us the current. So the analogous of velocity in SHM is this current in the LC oscillations. The mass is replaced with the inductance. Okay, K is replaced by 1 upon C. Half mv square, the kinetic energy here, is replaced with the energy stored in the inductor, half Li square, and the potential energy that used to be half kx square is now replaced with the energy stored in the capacitor, that is q square by 2c. So these are very basic things, and the questions that are asked on this topic are very easy if you just get them once. Okay, but they are very much important. So let's see the energy stored in the capacitor and the inductor. So as we know, energy conservation will be fulfilled always, right? Because here the energy conservation will be valid, so that I can say that the energy that is stored in the capacitor, the maximum amount of energy that is stored in the capacitor, that will be oscillated, and that same amount of energy will be again getting stored in the inductor. So I can say simply that the maximum amount of energy that will be stored in the capacitor and the maximum amount of energy that will be stored in the inductor will be same, because that's the same energy which is oscillating between the capacitor and the inductor. So whatsoever will be the maximum energy stored in the capacitor, Q naught square by 2C, and the maximum energy stored in the inductor, that is half L I naught square. So according to the energy conservation in the system, we can say that the maximum energy in the capacitor and the maximum energy stored in the inductor will be same. So I can say that Q naught square by 2C will be equal to half L I naught square. Okay, and most of the questions will be simply done with just the equation of this energy conservation. Okay, so without any delay, just see this question, that a fully charged capacitor C with initial charge Q naught is connected to a coil of self-inductance L at t equal to 0. We have to find that at what time is the energy stored is completely magnetic. The question is saying at what time energy stored is completely magnetic. Completely magnetic means at what time the energy will be completely stored in the inductor only. That means there won't be any energy stored in the capacitor. And if there isn't any energy stored in the capacitor, I can simply say that charge on the capacitor will be 0. Charge on the capacitor will be 0, right? And the equation of charge, the oscillation of charges that we have seen over here, that Q is equals to Q naught cos omega t. So just put the value in that equation, that we know Q is equals to Q naught cos omega t, and this charge is 0 at that moment when the energy will be completely magnetic. So it will be Q naught cos omega t. That means cos omega t will be equal to 0. That means omega t is equals to pi by 2 for the first time, right? So I can write omega as 2 pi by time period, this t as it is, and this is equals to pi by 2. Pi got cancelled out and we got that small t is nothing but equal to t by 4. We got the time at which the energy will be completely magnetic. That means at t equal to 0, the capacitor was connected with the inductor. Okay, the capacitor was connected to the inductor at t equal to 0 and t equal to t by 4. That means 1 by 4 of the time period of the oscillation, the energy will be completely stored in the inductor. Okay, so we got the time. Moving on to the next part of the question, it is saying at what times is the total energy shared equally between the inductor and the capacitor. The energy should be shared equally between the inductor and the capacitor. So if the energy is getting shared equally, so I can simply say that Q naught square by 2C will be equal to half L I naught square, right? The energy is getting shared equally. Right now I'm writing the expression of the maximum energy, and if it is getting shared equally, that means the energy that will be available in the capacitor will be exactly half of the maximum energy, because if it is getting shared equally, so energy will be half at that moment in the capacitor. So I can say that, let's say the charge of the capacitor, charge at the capacitor at that moment, let it be Q1. So Q1 square by 2C will be equal to half of the maximum energy stored. Q naught square by 2C is the maximum energy stored, and half of that will be stored at that moment, because half of the other energy, half of the remaining energy will be in the inductor, because it is shared equally, right? So let's cancel out the terms, and we got that Q1 will be nothing but Q naught by root 2. Q1 will be Q naught by root 2. So just by using the equation once again, that Q naught by root 2 will be equal to Q naught cos omega t. This cancelled out and we got that cos omega t is nothing but 1 by root 2. That simply means that omega t is nothing but pi by 4. So I can say 2 pi by t. I can write omega as 2 pi by capital T. This as equal to pi by 4. So pi and pi got cancelled out and we got that small t is equals to capital T by 8. That's what the answer to this question. Like at this time, t equal to t by 8 for the first time. Since the energy and the charges are getting oscillated, So they will be repeating the whole of the situation, like the energy getting shared equally, the energy is completely stored in the capacitor, the energy is completely magnetic. All of these phenomena will be repeated continuously, but these the time instants that we are receiving, they are for the times when the things are happening for the first time. Like the energy is completely magnetic for the first time at T by 4, the energy is equally shared between the capacitor and the inductor equally for the first time at T equal to T by 8. So these are the time instants for the first time. If we talk about the other time instants, as it is asking at what times is the total energy shared equally between inductor and the capacitor. So you can simply see that energy was completely stored in the capacitor at T equal to 0. And at T equal to T by 4, the energy is completely stored in the inductor. That means in 1/4 of the time, the energy has completely switched on from capacitor to the inductor. So if we talk about the other time instants, when the energy will be completely stored as magnetic, so I can simply say that if I will add T by 2 to this time instant, so I'll be getting again the total energy stored in the form of inductor. I can say it in this manner as well, that at T equal to 0, the energy was completely stored in the capacitor. At T equal to T by 4, the energy is completely stored in the inductor. Again after T by 4, the energy will be completely in the capacitor, and again after T by 4, the energy will be completely stored in the inductor. So when the energy was completely stored in the inductor, after that T by 4 time, the energy is in the capacitor, T by 4 time, the energy is again in the inductor. That means T by 4 plus T by 4. That means after T by 2 time, the energy will be again completely stored in the form of magnetic energy. So we can simply say that at T by 4, it was completely magnetic. Just add T by 2 to that. So you got 3T by 4. Again, add T by 2 to that. You got 5T by 4. So in this manner, we can say that at these time instants, the energy stored will be completely magnetic. At these time instants, T by 4, after that at T by 2, then again at T by 2, the energy stored will be completely magnetic. I hope you guys got it. Talking about when the energy will be shared equally. So similarly, as we can say that the energy from capacitor to the inductor moved from T equal to 0 to T by 4. Okay. From T equal to 0 to T by 4, the energy switched from capacitor to the inductor. So during the first shift, the energy would be equally shared between the capacitor and the inductor. That means I can say once in every T by 4 seconds, once in every T by 4 time, the energy will be equally shared between the capacitor and the inductor. So I can say that if once it is stored at T by 8, then after every T by 4 time, it will be shared equally. Because from T equal to 0, this was T by 4. Energy was completely stored in the capacitor. Energy is completely stored in the inductor. In between that, at time T equal to T by 8, the energy is equally shared. So after again T by 8 plus T by 8. That means after T by 4 time, the energy will be again completely stored in the shared equally between the capacitor and the inductor. So yeah, we can say that first for the first time, if it is stored at T by 8, if it is stored equally at T by 8, so just add T by 4 into that. So T by 8 plus T by 4, we got 3T by 8. Again add T by 4 to that, you got 5T by 8. So just we got the thing that if it is first stored at T by 8, which will always be if at T equal to 0, the energy was completely capacitive. So at T by 8, then 3T by 8, then 5T by 8 and so on. After the regular intervals of T by 4, the energy will be shared equally between the inductor and the capacitor. So I hope you guys got it. This is the very important concept, okay, and it may be complicated as well in the first go, but if you will, like if you have any doubts in this, I will just simply suggest you to rewatch it once again and it will be crystal clear to all of you guys. Okay, but it is very much important. You just have to remember that when the energy will be completely magnetic and when it will be equally shared between the inductor and the capacitor. So, phase difference between charge and the current will be pi by 2, right? And when charge will be maximum, current will be minimum, because yeah, the energy is getting oscillated between the capacitor and the inductor. So if the charge is maximum, that means the maximum energy is stored in the capacitor. So obviously the minimum energy will be stored in the inductor. So current will be minimum, and when charge will be minimum, current will be maximum. And for the same reason, we have the phase difference of pi by 2 between the current and the charge. Okay. So let's see one example on this, that a RC series circuit of resistance 15 ohm and capacitance 1 microfarad is connected to 20 volt DC supply for very long time. The capacitor is disconnected from circuit and connected to inductor of 10 millihenry. Calculate amplitude of the current. We have to calculate simply the amplitude of the current. So if I want to calculate the amplitude of the current, I simply just be using the concept of energy conservation, because you guys will simply notice this. Why? See, I know that it was earlier connected to a DC source of 20 volts. So I simply know that how much energy will be stored in the capacitor, half CV square. This will be the energy stored in the capacitor in the beginning. And this maximum energy will be the same energy that will be stored in the inductor as well. Because maximum energy, when it is stored in the capacitor, it is stored only in the capacitor. And when it is stored maximally in the inductor, it is stored only in the inductor. So that same energy is getting oscillating between inductor and capacitor. So maximum energy stored will be same according to energy conservation. So this half CV square will be equal to half L I naught square, the maximum current in the inductor. So that same energy will be oscillating. So in terms of capacitor, I can write the energy in this manner. And in terms of inductor, I can write the energy in this manner. So let's simply put the values. C is 1 microfarad. V is 20 volts. So square of that becomes 400. It will be half. This is 10 millihenry and I naught square. So how much it is coming out to be? This half cancelled out. Okay. And 10 raised to the power minus 3, it becomes 10 power minus 3 again. And I naught square can be written as 10 power minus 3 by again 10. So it becomes 400 into 10 raised to the power minus 4. So I naught will be simply equal to root of 420 and root of 10 power minus 4, 10 power minus 2. So I simply got the value of I naught as nothing but 0.2 amperes. That will be the maximum current, or I can say that's the amplitude of the current, 0.2 amperes. So I think this question was very easy, but again very important. It's just once you get the question, it becomes very easy. That's what the thing is, right? So it was asking the maximum value of the current, or I can say the amplitude of the current. So we just simply use the energy conservation and we got the value. I hope you guys got it. Moving on to the next one. A condenser of capacity C is charged to a potential difference of V1. The plates of the condenser are then connected to an ideal inductor of inductance L. Okay. The current through the inductor when the potential difference across the condenser reduces to V2 is. So initially that condenser, or I can say the capacitor, was connected to V1. So initially the energy stored in the capacitor was half CV1 square. Finally, when the potential difference reduces to V2, so now the energy stored in the capacitor will be half CV2 square. And if the potential difference has reduced, so definitely energy must have been reduced. Where the remaining energy has gone? Into the inductor, obviously, right? So let's say the energy stored in the inductor at that time is, let's say, half Li square. Okay. We have to find the current through the inductor when the potential difference across the condenser reduces to V2. So this was the initial energy stored when the potential difference was V1. Now when the potential difference becomes V2, this is the energy stored in the capacitor, and the remaining energy will be stored in the inductor. And according to the energy conservation, these energies should be equal. The question is finished. These energies should be equal according to energy conservation. So let's now simply put the values. Okay, we don't have to put the values, we just have to solve it in the terms of variables only. So I can simply write it as half C V1 square minus V2 square. This is equals to half Li square. This cancelled out and we got the value of I square as C by L V1 square minus V2 square. This is the value of I square. So the value of I will be nothing but root of this term. Okay, half C V1 square minus V2 square, half Li square, C by L and V1 square minus V2 square. Yes, that's the value of the current at the moment when the potential difference will be reduced to V2. So that's the value of I we received. Again, the question simply got solved with the help of energy conservation. I hope you guys got it. So that's all from my side for today's one. I hope you guys got all the concepts. If you still have any doubts, you can simply let me know in the comment section. And don't forget to watch the whole playlist, the link given to you in the description. Thank you so much.